NEC Section 430.102b addresses the use of a motor control center, or MCC, as service equipment under specific conditions. To utilize an existing MCC to feed a new panel, several requirements must be met. Firstly, the MCC must be dedicated to serving equipment within the building. This means the MCC primary function is to supply power to the building's electrical systems and equipment. Secondly, the MCC must be designed and installed in accordance with Article 430 Part 5 of the National Electrical Code. This section of the NEC outlines the construction, installation, and safety requirements for motor control centers. Thirdly, the MCC must be suitable for use as service equipment. This involves having several key components and features. 1. A main disconnect or circuit breaker that can de-energize the entire MCC in case of an emergency or for maintenance purposes. 2. Overcurrent protection for each circuit within the MCC to protect against overloads and short circuits. 3. A grounding bus to provide a low impedance path for fault currents back to the source. And 4. Provision for overvoltage protection to safeguard equipment from voltage surges and transients. Beyond these specific requirements, there are several important considerations to keep in mind when planning to feed a new panel from an existing MCC. 1. The available capacity within the MCC must be sufficient to supply the new panel and its associated load. This involves calculating the total load of the new panel, including all the equipment it will be powering, and ensuring that the MCC has enough spare capacity to handle this additional load without overloading. 2. The new panel must be properly rated and protected for the load it will be supplying. This means selecting a panel with an appropriate ampacity rating and installing overcurrent protection devices, such as circuit breakers, to protect the panel and the equipment connected to it. 3. The existing 90.3 amp breaker in the MCC bucket may need to be replaced with a higher rated breaker to provide sufficient protection for the new panel. The size of the breaker should be determined based on the calculated load of the new panel and the ampacity of the conductors feeding it. 4. The wiring from the MCC to the new panel must be properly sized and installed in accordance with the NEC. This includes using conductors of the correct ampacity rating, installing them in approved raceways or cable assemblies, and ensuring that all connections are made properly. It is crucial to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. Electricians possess the knowledge and experience necessary to properly assess the existing MCC, calculate the load requirements of the new panel, and select and install the appropriate equipment and wiring. A local electrical inspector having jurisdiction may have additional requirements or limitations that must be followed. The electrical inspectors are responsible for enforcing the NEC and other applicable codes and standards, and they can provide valuable guidance on how to ensure that an electrical installation is safe and compliant. When considering the capacity of the MCC, consider the existing load in the MCC. Determine the total demand of all existing loads connected to the MCC. Next, calculate the load of the new panel, including all the HVAC units and other equipment it will supply. Ensure that the MCC has enough spare capacity to accommodate the new panel's load without exceeding the MCC overall rating or overloading any of its components. When selecting overcurrent protection for the new panel, choose circuit breakers with an appropriate ampacity rating to protect the panel and the equipment connected to it. The breaker size should be based on the calculated load of the panel and the ampacity of the conductors feeding it. Consider using circuit breakers with features such as ground fault protection to enhance safety. When sizing the wiring from the MCC to the new panel, use conductors of the correct ampacity rating to carry the load. Refer to NEC Table 310.16 for ampacity ratings of conductors based on their size, insulation type, and installation method. Install the conductors in approved raceways or cable assemblies, such as conduit or cable trays, to protect them from physical damage and environmental factors. Ensure that all connections are made properly using approved connectors and terminals, and that the connections are tight and secure. Consider the location of the new panel relative to the MCC. If the panel is located a significant distance from the MCC, voltage drop may become a concern. Voltage drop occurs when the voltage at the load end of a conductor is lower than the voltage at the source end due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, use larger conductors or install the panel closer to the MCC. Calculate the voltage drop using a voltage drop calculator or consult with an electrician to determine the appropriate conductor size for the distance and load. Ensure that the new panel is properly grounded in accordance with NEC Article 250. Grounding provides a low impedance path for fault currents back to the source, which helps to protect people and equipment from electrical shock and damage. Connect the grounding conductor from the new panel to the grounding bus in the MCC. Use approved grounding connectors and terminals to ensure a reliable connection. Consider the use of surge protection devices to protect the new panel and the equipment connected to it from voltage surges and transients. Surge protection devices divert excess voltage to ground, preventing it from damaging sensitive electronic equipment. Install surge protection devices at the main panel and at individual equipment locations as needed. Coordinate the installation with other trades working in the area to avoid conflicts and ensure a smooth and efficient installation process. Communicate with the electrical contractor, HVAC contractor, and other trades to coordinate schedules and ensure that all work is performed in accordance with the plans and specifications. Obtain all necessary permits and inspections from the local authorities before starting work. Electrical permits are required for most electrical installations, and inspections are conducted to ensure that the work is performed in accordance with the NEC and other applicable codes and standards. Schedule inspections at the appropriate stages of the project and address any deficiencies promptly. Maintain accurate records of all work performed, including wiring diagrams, equipment specifications, and inspection reports. These records will be useful for future maintenance and troubleshooting. Label all circuit breakers and other components in the new panel clearly and accurately. Proper labeling will make it easier to identify and troubleshoot circuits in the future. Provide training to the facility staff on the operation and maintenance of the new panel and the equipment connected to it. This training should cover topics such as safety procedures, troubleshooting, and preventive maintenance. Regularly inspect and maintain the new panel and the equipment connected to it. Perform routine inspections to check for loose connections, damaged wiring, and other potential problems. Replace any worn or damaged components promptly. Keep the panel clean and free of debris to prevent overheating and other issues. Before undertaking any electrical work, always de-energize the circuit or equipment and verify that it is de-energized using a voltage tester. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical hazards. If you are not qualified to perform electrical work, hire a qualified electrician to do the job. When evaluating the MCC, check its overall condition, including the enclosure, wiring, and components. Look for signs of damage, corrosion, or overheating. Ensure that all components are properly mounted and secured. Verify that the MCC is properly grounded in accordance with NEC Article 250. Check the grounding connections and ensure that they are tight and secure. Inspect the busbars and conductors for signs of damage or overheating. Look for discoloration, melting, or other signs of excessive heat. Verify that all circuit breakers and fuses are properly sized and labeled. Check the interrupting rating of the circuit breakers to ensure that they are adequate for the available fault current. Inspect the motor starters and contactors for signs of wear or damage. Check the contacts for pitting or erosion. Verify that the overload relays are properly set to protect the motors. Inspect the control wiring for signs of damage or deterioration. Look for frayed insulation, loose connections, or corrosion. Test the operation of the MCC to ensure that all components are functioning properly. Simulate various operating conditions and verify that the MCC responds as expected. Verify that the MCC is properly ventilated to prevent overheating. Ensure that the ventilation openings are not blocked by debris. Consider performing infrared thermography to identify hot spots in the MCC. Infrared thermography can detect areas of excessive heat that may indicate a problem with a component or connection. Document all findings and recommendations in a written report. Provide the report to the facility owner or manager and discuss any necessary repairs or upgrades. When selecting a new panel, choose a panel with an appropriate ampacity rating for the load it will be supplying. The ampacity rating of the panel should be equal to or greater than the calculated load of the panel. Choose a panel with an adequate number of circuit breaker spaces to accommodate all of the circuits that will be connected to it. Consider using a panel with a main circuit breaker to provide overcurrent protection for the entire panel. Choose a panel that is suitable for the environment in which it will be installed. If the panel will be installed in a damp or wet location, choose a panel that is rated for wet locations. Choose a panel that is easy to install and maintain. Consider using a panel with features such as hinge doors and removable interior panels. Choose a panel from a reputable manufacturer with a good warranty. When installing the new panel, mount the panel securely to a wall or other suitable support. Ensure that the panel is level and plumb. Connect the grounding conductor from the panel to the built-in grounding system. Use approved grounding connectors and terminals. Connect the branch circuit conductors to the circuit breakers in the panel. Ensure that all connections are tight and secure. Label all circuit breakers clearly and accurately. Create a circuit directory that identifies the load served by each circuit breaker. Test the operation of the panel to ensure that all circuits are functioning properly. Use a voltage tester to verify that the voltage at each circuit breaker is within the acceptable range. Use an ammeter to measure the current on each circuit. After the installation is complete, provide training to the facility staff on the operation and maintenance of the new panel. In addition to the NEC requirements, local codes and regulations may also apply to the installation. Be sure to check with the local authorities to determine if any additional requirements or limitations exist. Failure to comply with all applicable codes and standards can result in fines, penalties, and even legal action. Therefore, it is essential to ensure that all electrical work is performed in accordance with the applicable codes and standards. By following these guidelines, you can ensure that the installation of a new panel fed from an existing MCC is safe, compliant, and reliable. Always prioritize safety and consult with qualified professionals when working with electricity. When examining the existing 90.3 amp breaker, verify its condition. Check for any signs of damage, overheating, or corrosion. Ensure that it is properly seated in the MCC bucket and that the connections are tight and secure. Determine if the 90.3 amp breaker is adequately sized to protect the new panel and its load. Calculate the total load of the new panel, including all the HVAC units and other equipment that will be connected to it. Compare the calculated load to the ampacity rating of the 90.3 amp breaker. If the calculated load exceeds 80% of the breaker's ampacity rating, then the breaker is not adequately sized and should be replaced with a larger breaker. Consider the inrush current of the HVAC units when determining the appropriate breaker size. HVAC units often have a high inrush current when they start up, which can trip a breaker that is too small. Consult the HVAC unit manufacturer's specifications to determine the inrush current and select a breaker that can handle it. If the 90.3 amp breaker needs to be replaced, choose a breaker with an appropriate ampacity rating and interrupting rating. The interrupting rating of the breaker should be equal to or greater than the available fault current at the MCC. Ensure that the new breaker is compatible with the MCC bucket and that it is properly installed and connected. After replacing the breaker, test its operation to ensure that it is functioning properly. Use a circuit breaker tester to verify that the breaker trips at the correct current level. When running the wiring from the MCC to the new panel, use the correct type and size of wire for the application. The wire should be rated for the voltage and current that it will be carrying, and it should be suitable for the environment in which it will be installed. Refer to NEC Table 310.16 for ampacity ratings of conductors based on their size, insulation type, and installation method. Install the wiring in approved raceways or cable assemblies, such as conduit or cable trays, to protect it from physical damage and environmental factors. Use proper wiring techniques to ensure that the wiring is installed safely and reliably. Avoid sharp bends in the wiring, and ensure that all connections are tight and secure. Protect the wiring from physical damage by using appropriate protection devices, such as bushings and strain reliefs.